Okay, this is a continuation of the practice test for MAC1140 Pre-Calculus. We're talking about the topics on exam number 3, which covers sections 11.1 through 11.6. In the review, we have moved on to section 11.5, partial fraction decomposition, and that's problems 49 through 55 in the practice test. Okay? There are various versions of partial fraction decomposition. They are based on the denominator. So the denominator, once it is all factored, because this process begins with you completely factoring the denominator. So when the denominator is all factored, you may have just linear factors and nothing but linear factors that don't even repeat. So that's one case, that's the easiest case. You may have linear factors that do repeat, and that bumps it up a notch. You might also have second degree factors, and we call those irreducible factors. When you can't break them down to first degree, they're called irreducible factors. You may have irreducible factors in your denominator that don't repeat. You may have some that do repeat, and thus the various cases. So we're going to begin with the easiest case. That's number 49, and I believe also 50, where all of the factors in the denominator are first degree and they don't repeat. Okay, these problems have a lot of work, so I have copied them to separate paper, and that's where I'm going to work it out. This is number 49. Okay, so 49, like I said, this process begins with you factoring the denominator. And when you factor this denominator, you're looking for two numbers that multiply to give you 42, but add up to give you 13. So that's going to be 7 times 6. That adds up to 13. And if you make the 7 as well as the 6 both negative, then when you add them up, you'll also get that middle term. Once again, you should be able to, I'm using the guess and check method for factoring this second degree trinomial. And guess and check just means you're looking for two numbers that multiply together to give you the constant, but add together to give you the linear coefficient. Notice that both of these factors are first degree and neither one of them repeats. You'll know that they repeat when your factors have a power of 2 or higher. That means you have a repeating factor, a factor times itself. Okay, so when you see that the factor is first degree, then it gets assigned a constant to it. So this would be a over x minus 6. Okay, this is also first degree, so it gets a constant for its numerator. Okay, then you're going to take this and you're going to multiply by the LCD. And that would be something that you can multiply the equation by that'll knock out each and every denominator that you have here. So this denominator has the most, and basically your LCD is going to just be the denominator of the fraction on the left. Not the denominators of the fractions that you created, but rather the main fraction that you began with, the one you're trying to decompose. So that LCD, just look at the denominator, and that's what you're going to be multiplying by. Okay, so now we're going to create an equation that doesn't have any fractions in it. When you multiply this LCD times the first fraction, it kicks out both of these factors, leaving you with just the numerator. When you multiply the LCD by this next term, the x minus 6 cancels with the x minus 6, and you're left with a, what's on the top, times x minus 7. When you multiply this LCD by the third term, the x minus 7s will cancel, and you'll be left with b times x minus 6. And now you have an equation, no fractions. You can multiply it out, and you're going to try and find A and B. So one of the easiest ways to find A and B is to think about the numbers that zero out the factors. Okay, these factors are now here. They're part of this equation here. So you want to look in here and ask yourself, what would zero this out? What would zero this out? Because that is the easiest way to go after the value in the numerators. When that doesn't work and you've exhausted all possibilities with respect to zeroing out the expressions that you see here, then you have to move to the technique of comparing like degrees on both sides of the equation. So I'm going to start by recognizing that what would zero this out would be x equal to 7. And that means everywhere in the equation that I've just created, I'm going to allow x to be 7. So that would give me 7 on the left. It would cause a 0 to happen here. 0 times a would wipe out that entire term. If I allow x to be 7 right here, it would be 7 minus 6 is 1. 1 times b. You now know the value of b. Okay, the other value that would zero out this expression would be 6. So allow x to be equal to 6. And if you allow x to be 6, you would have a 6 on the left. You'd have 6 take away 7 here, negative 1. Negative 1 times a is negative a. And if you completely solve this where you strip the a of its negative 1 multiplier by dividing both sides by negative 1, you would have a is equal to negative 6. Okay, so in this problem, the main fraction, which was x over x squared minus 13x plus 42, decomposes into a over x minus 6, and we now know that that a value is negative 6, plus b over x minus 7, and we now know that the b value is 7. Okay, with respect to the answers that you're seeing here, negative 6 belonging to x minus 6, that would be that one, and 7 belonging to the denominator x minus 7. So that would be choice D for 49. Let me check those as we go along. Yes, that's correct. Okay, moving on to 50. Okay, here's problem 50. Okay, this one just happens to already be factored in the denominator, so you can jump right into splitting up the main fraction into the decomposed fractions. Remember, any factor that is linear, first degree. This one is first degree, this one's first degree, this one's first degree. Gets assigned a constant as its numerator when you start decomposing it into these baby fractions over on the right-hand side. So this factor gets a constant, I'll call that A, as its numerator. This factor, x plus 4, also gets a constant as its numerator, but that constant has to be different than this one. And the factor x minus 1, since it's first degree, it gets assigned a constant as well, and that constant has to be different than these two. So now this time, we did get the little break that the bottom was factored already, but now we have to find A, B, and C. Okay, so first thing we're going to do is wipe out all these fractions by multiplying by the LCD. The LCD will be apparent in the main fraction. It will be the denominator all factored out. That's what your LCD is going to be. So this least common denominator is going to get multiplied by everything on the left as well as the right. Okay, so when we start multiplying, first we're going to multiply it by this fraction. This entire LCD will knock out everything in the denominator, leaving you with just the terms in the numerator of this fraction on the left. So you'll be left with 9x squared plus 4x plus 12. when you multiply this LCD by this fraction, this x would cancel with this x, leaving you with x plus 4 times x minus 1 times a. Those are all the things that would not cancel, and therefore they remain. So a times x plus 4 times x minus 1. When you multiply the LCD by this next fraction over on the right-hand side, the x plus 4 would cancel with this x plus 4, leaving you with x times x minus 1 times b. X times x minus 1 times b. You can just put those constants out front. And then finally, when you multiply the LCD by this last term over on the right-hand side, the x minus 1 in the denominator would cancel with the x minus 1 in the LCD. You'd be left with x times x plus 4 times c. Okay, again, the easiest way to find the values in the numerator is to think about what would zero out each of these factors. However, sometimes that won't allow you to find all the values that you need to find. So when you can't find everything you need by doing it that way, you'll move on to comparing like-degreed terms on each side. Okay, but I'm going to first try, obviously, whatever's easiest. What would zero out this factor right here would be negative 4. So I'm going to allow x to be equal to negative 4 and see what that helps me to find. Okay, right now, plugging in negative 4 everywhere that I see an x. Let me get my calculator. Okay, so if I'm going to put negative 4 right in here, that would be negative 4 times negative 4, 16. 16 times 9, which is 144. If I put negative 4 in there, that's going to be negative 16. 4 times negative 4 is negative 16 plus 12. And if I combine all these numbers, 144 minus 16 plus 12, that's going to give me 140 on the left-hand side. Moving over to the right side and continuing to allow x to be equal to negative 4. If I allow x to be equal to negative 4 right here, that would cause a 0 in one of the factors. Therefore, it would zero out this entire term. If even one of these factors is 0, it turns the entire term to 0. So this zeroes it out. Allowing x to be equal to negative 4 here would be negative 4 minus 1, which would be negative 5. Negative 4 minus 1 would be negative 5. That negative 5 would be multiplied by negative 4 yet again, because I'd have to plug the negative 4 in there as well. And then I would have times b. So negative 4 times negative 5 would be positive 20 times b. Okay, then when you plug in negative 4 into this term, it would be a 0 here. 0 times this term times the rest of the factors in this term makes this whole term 0. So that would wipe out that term. It would completely wipe out this term. So the only thing that would remain is this term, and I just said that when you plug in negative 4, you get a negative 5 times negative 4 is 20. 20 times b is 20b. So this is the equation that we have upon allowing x to be equal to negative 4. Now divide by 20 on both sides, and you end up with b is equal to 7. Okay, so we have one value, and let's go on to try and find the other numerators. Okay, just trying to get a highlighter so I can keep track of what I've found. Okay, so allowing x to be equal to -4 got me the b value. Now let me look at these other factors. The other factor here is one of the other factors is x minus 1. So if I let x be equal to +1, that will zero this out, and thereby it is a value that's going to allow me to find yet another one of these numerators. Okay, so everywhere that I see an x, I'm going to put in a 1. So starting on the left-hand side, 1 squared will be 1. 1 times 9 is 9. Plus 4 times 1 is 4, so plus 4. Plus 12. So on the left-hand side, upon allowing x to be equal to 1, I get a 25. When I move over to the right-hand side, if I allow x to be equal to 1 here, I get a 0, thereby wiping out this entire term. If I allow x to be equal to 1 in this second term, I get another 0, thereby wiping out this entire second term. If I allow x to be 1 in this third term, it's 1 plus 4, 5. 5 times 1, because I'm letting x be 1, would be 5, 5c. Divide by 5, divide by 5, and you get c is equal to 5. So now I know another one of the numerators in my over on my decomposed side. Now I'm going to move to allowing the last factor that I have not yet allowed to be 0, and that would be this x. I'm going to let x be equal to 0, because there's 3 factors here, x minus 1, x plus 4, and an x. So when you allow x to be equal to 0, that would 0 out this term, 0 out this term, leaving you with just 12 on the left-hand side. On this side, if you allow x to be 0, you would have 0 plus 4, 4. 0 take away 1, -1, and then times that a. -1 times 4 is -4, -4a. And then let's move to the next term and let x be equal to 0 there. If I allow x to be 0 right here, it'll wipe out this entire term, because if even one of these factors is 0, the whole term turns to 0. Moving over here, I experience the same situation. Letting x be equal to 0 wipes out that entire third term. Coming now to solve for a, you would divide by -4 on both sides, ending up with -3. Okay, so now we have found a, b, and c. So the main fraction that we started with, I'm just going to write what it decomposes into just to save a little time here, but this is the main fraction that we started with. We were decomposing it into these little baby fractions here, and you just have to make sure that you get the right numerator with the right denominator, because you wouldn't want to match them up improperly at the end of the problem. Okay, so your a value goes with x. My a value turned out to be -3. That is assigned to the denominator of x. Then next we have the b that goes with the x plus 4. The b value turned out to be 7, denominators x plus 4. Okay, next is c. That c value turned out to be 5, and that c value gets assigned to the denominator x minus 1. As far as the answers on this practice test, for number 50, these were the choices. So let's see, -3 goes with x, 7 goes with x plus 4, b looks pretty good, and then 5 goes with x minus 1. So it appears to be b. Let me check that out. Yep, that's correct. Okay. All right, so that's number 50. Okay, moving to 51. Okay, problem 51, you now move a step up where you still have linear factors. In other words, the factors, the base of your factor, it's still first degree. However, once you move to this problem, you've moved into a situation where one of your linear factors is repeated. And once it's repeated, you have to use a technique where you build up to the highest power. But as far as what you're going to assign to the numerator, it's still just a matter of your factors are first degree. I'm going to point that out to you. Look at the factors that are in this denominator. This factor, without looking at any kind of power that's attached, this base, this factor is first degree. Therefore, when you start breaking it up over here, it does get a constant as its numerator. So A is assigned to x plus 2. This factor, even though it has a power of 2, that just means that it repeats, but this base is still first degree. In other words, what's inside the parentheses is first degree. So anything that you assign to it as a numerator has to be a constant. But when there's a repetitive situation going on in the problem, you have to build up to that power. So you're going to have a constant assigned to x plus 1 first to the first degree. And then use a constant again, but now you're building up to second degree. Put those away. I'll put those dishes away. Hold on one second. I'll put these away. Okay, so I was just talking about how you build up to any kind of a repetitive power. So now these are the little baby fractions that we have decomposed the main fraction into, and jump into multiplying by the LCD because you do want to wipe out all these fractions before continuing with the problem. Okay, so this is going to be x plus 2 is one of the factors, and then x plus 1 squared is the other part. Again, that denominator that's in your main fraction is going to be it's always going to be your LCD. Because that LCD has to be strong enough to kick out the denominator in the main fraction, and therefore that's why it's always the LCD that you're going to use. So when you multiply this LCD by the first fraction, it kicks out the entire denominator because it matches. And what you're left with is everything in the numerator. So negative 7 x squared minus 15x minus 7. Then when you multiply the LCD by A, that x plus 2 in the LCD cancels with the x plus 2 in the denominator, leaving you with A times x plus 1 squared. Okay, next you're going to multiply the LCD by the second fraction over on the right-hand side. X plus 1 in this denominator cancels with one of the x plus 1's in this repetitive factor. So one of these cancels with one of these. You are going to have an x plus 1 left over. You're going to have an x plus 2 left over and a b. Okay, you're going to have an x plus 1 left over and an x plus 2. Finally, multiplying that LCD by the third fraction, both of these x plus 1's cancel with both of the x plus 1's in the denominator here. So this cancels with this. You're left with x plus 2 times c. Okay. So now let's go with the technique that is the easiest way for finding the values in the numerators, and that would be figuring out the values that zero out the factors. If we are not able to find all the values in the numerator, then we are going to move to another technique where we compare the degrees. Okay, so one of the values that would zero out this factor right here would be x equal to -1. Let x be equal to -1, and we'll see what that finds us. Okay, so moving right in here, anything squared is positive. So when you put a -1 in there, it's +1. But then when you multiply it by -7, you get -7. Okay, plugging a -1 in there is 1. 1 times -7, -7. -15 times -1, +15. And then -7, just bring that down. So this is 15 combined with -14, 1. Okay, moving to the right-hand side. When you let x be equal to -1, that zeroes out this first term. It also zeroes out this term because you'd be plugging the -1 right in there. So that gets rid of this term, gets rid of this term completely. All you're left with is the term containing c. We are plugging in -1 right now. So -1 plus 2 is 1. 1 times c, c. Okay, you now know what your c value is. Okay, then let's get up in the expression again and look at the other factors. We have another factor called x plus 2. So let's see what allowing that, the value that allows that to be 0 would be -2. So let's let x be equal to -2 and see which of the numerators we get by doing that. So when you put -2 in there, that's 4. 4 times -7 is -28. I'm going to keep track of it right here. If you put -2 right in there, -2 times -15 is +30. And you can put the whole thing in your calculator if you want to. And then -7 would be -7. Combining all three of these numbers, that would be 2 minus 7 is -5. Okay. All right, then let's see what's left here. So we did the left-hand side. Now we're going to plug in -2 into each of the expressions on the right-hand side. If you put -2 right in there, -2 plus 1 is -1. -1 squared is 1. Anytime you square something, it comes out positive. So that would be 1 times a. Okay, when you go and plug -2 into this next expression, you end up with a 0 here, thereby zeroing out this entire second term. When you plug in -2 into this third expression, it zeroes out that one as well. So those two are completely gone, and you are only left with the a value. Okay, let's check that one more time. That would be -1. -1 squared is 1. 1 times a is a. Zeroes out this one, zeroes out that one. So now we also know the a value. However, we finally get to a problem in number 51 where we've used every value that we can possibly come up with that's going to zero out these factors. We only have two factors, x plus 2 and x plus 1. And we've already used the values that zero those out. So we have exhausted the technique of being able to find these numerators by using values that zero out the factors. So now we need to move to something else. And that would be comparing like terms on each side. Now you can either compare constants, you can compare first degree terms, you can compare second degree terms, just as long as they're like terms on each side. We're ultimately going to move to comparing the coefficients. So I'm going to start by comparing second degree terms on both sides. So second degree term here is -7x squared. Over on the right hand side, now you don't need to completely FOIL this out, but if you did begin to FOIL this out where you would go x plus 1 times x plus 1, the very first term would be x squared. You only need to worry about that term because we're only comparing second degree terms. So x squared times a is your first second degree term on the right hand side, and this is its coefficient. Likewise in this second term over on the right hand side, if you were to partially FOIL this out, in other words, just consider that very first product of the FOILing process, you would get x squared times b would be bx squared. So there's another second degree term. When you get to this third term, there are no second degree terms, so that's it. Those are all the second degree terms. Now, once you have identified all the second degree terms, you are simply going to work with the coefficients only. Only use those coefficients. So, coefficient of this second degree term, -7. Coefficient of this second degree term, A. Coefficient of that second degree term, B. So now we have a nice little equation, A plus B is equal to -7, but yet we already know what A is. So it's -7 is equal to -5 plus B, and there we go. We have an equation that's going to allow us to find that last missing value in number 51. So this is... I'm going to bring this -5 over to the other side. When it goes to the other side, it becomes +5. -7 combined with +5 is -2, and that is equal to B. Okay, so we have all three values, and then let's try and find the answer that goes with this. Now, I think that, just for your clarity on picking an answer, you should probably write out what the right-hand side looks like. You don't necessarily need to write that main fraction, but make sure that you properly pair up the values that you have found with the correct denominators, because that's an easy way to get it wrong. So A gets paired with x plus 2. That A value is -5, so one of your decomposed fractions looks like this. The B value gets paired with x plus 1, so you have that. And I just, I want to make a comment here that when you're looking through the answers, they could very easily just take this negative, and float it right into the middle there. If they float it into the middle, then that means they're going to leave the two positive. That's just another way of writing that. A positive, so I'll write it in both ways. I'm going to write it this way, and let me continue. I now need the C value with this x plus 1 squared. That C value turned out to be 1. So it would look like this. And just so you are very aware of this situation right here can be written like this. When you have double signage in there, they can float that negative into the middle, and that would leave the top positive. So if you're answering this question freestyle on the test, I'll take either form of the answer. Now let's see what they offered on this test. So this is number 51. So we need something where the -5 is paired with x plus 2. They left the double signage in there from what I'm seeing here on the answer. So it's positive, and then a negative goes with the x plus 1, and then, so that appears to be choice B. Okay, let me check these answers on the answer key. 51, yes, it is B. Good. Okay, moving on to 52. So 52. Okay. All right, so this is just another one of those kind of problems. I mean, I thought you would probably need more practice on the ones where the linear factors are being repeated. So I've given you 2 of those. This is another one just like that. You have to build up to this repetitive power that you're seeing here. However, notice that this base is first degree. So if you're going to assign it a numerator, this is first degree too. If you're going to give it a numerator, it has to be a constant whenever that base is first degree. Okay, so doesn't matter which fraction you create first. I'm going to do this one first, the one that doesn't repeat. Okay, since the denominator is linear, first degree, you use a constant for its numerator. Okay, then for this one, build up to that power of 2. First use it at its first, raised to a power of 1. This will be the numerator. Then you can build up to that power of 2. And if you had something that was to the third degree, you would use it to the first degree, then the second degree, then the third degree. You would slowly build up to that power. Okay, like we have started all the rest of the problems, you're going to get in here and multiply by the LCD, which is nothing more than the denominator in the main fraction. So that LCD is x minus 2 squared times x plus 4. Okay, you're going to multiply it by the main fraction. All of the LCD will cancel with everything in the denominator. So that whole denominator is gone, leaving you with just x plus 1. Okay, moving on to the items on the right-hand side. When you multiply this LCD by this first fraction, this x plus 4 would cancel with this x plus 4, leaving you with x minus 2 squared times a. Okay, when you move to this next fraction, the x minus 2, this x minus 2 would cancel with one of these x minus 2's and leave you with one x minus 2 left over. So just this would cancel with just one of these. So you'd have an x minus 2 left over and x plus 4 times the b there. X minus 2 left over and an x plus 4. Okay, then multiplying by this third fraction. This entire x minus 2 squared would cancel with this x minus 2 squared, leaving you with c times x plus 4. I'm going to do what I've done in all the previous problems. I'm going to first find anything and everything I can find from the values that zero out these factors. Your factors are just x plus 4 and x minus 2. Those are the only factors you have. Therefore, the only zeros you have are positive 2. That would zero out one of the factors. So I'll be able to find one of these numerators by allowing x to be equal to 2. The other number that zeroes out the factors is going to be negative 4, and I'll try that next. So let's go with x equal to 2 right now. If I allow x to be 2 right here, 2 plus 1, 3. If I come over to the right-hand side and I put a 2 right in here, that would zero out this term, thus getting rid of the entire first expression. Whoops, I have too many equal signs. This should have been a plus sign in front of that b expression. Okay. Excuse me. If I let x be equal to 2 right here, that would cause a 0 here. 0 times anything else that's in this term right here would get rid of the entire term. If I let x be equal to 2 here, 2 plus 4 is 6. 6 times c, 6c. Okay, solving this, I would be dividing off this coefficient of 6, and I would end up with c is equal to 1/2. Okay, so I have one of the values so far. Okay, moving on to the next value. That would zero out a factor, and that would be, as I mentioned earlier, x equal to negative 4. Okay, when you put negative 4 in here, it's negative 4 plus 1, negative 3. Negative 4 minus 2 is negative 6. Negative 6 squared, anything squared is positive, so it's just the same thing as squaring 6. So negative 6 squared is 36, 36 times A. If I put a negative 4 right here, I get a 0, thereby zeroing out this entire term. If I put a negative 4 in here, it zeroes out this entire third term on the right-hand side. So all I have left is this little expression, and if I divide by 36 here, as well as 36 here, I end up with A is equal to 1, and if you want to reduce that, it's 12. 3 goes into here 12 times, so this reduces to 3 goes into the top 1 time, 3 goes into the bottom 12 times, but you do know how to reduce with your calculator, even though I'll mention it again. You just put the entire fraction into your calculator, 3 divided by 36, and hit math, enter, enter. And that'll reduce it for you if you want to reduce that way. So now we have another value. However, we have run out of numbers that would zero out the factors. So now all you can do is start comparing like terms to try and find other values. So I'm going to try compare second degree. So second degree, on the left side, notice that we don't have any second degree terms. That's the same thing as saying I have 0 of this particular term. When you get over here, if you were to FOIL this out, you'd have x plus 2 times x plus 2, and that very first product would be x squared. You don't need to get the rest of the terms. Just x squared times a is ax squared. If you were to begin FOILing this out, that very first product, again, would be x squared times b gives you bx squared. And only that very first product is a square term, so you only need to worry about that if you're comparing second degree terms. Let's see, and then in this one right here, you would have c times x. Oh, but we're only comparing second degree terms, so that means that's it. That's all the second degree terms that you have. Once you identify all the like terms that you happen to be comparing, right now it's second degree, then go to simply comparing the coefficients. You can just yank those coefficients right off of the second degree terms. So 0 is equal to a plus b. Okay, then after that, what you're going to do is realize that you have the a value already. You have negative 1/12 for your a value, but that allows you to find your b value. So you're going to move this over here, and it will become positive 1/12. So now you're going to have b is equal to 1/12. And that is your third value. Now just make sure that you get all of these assigned to the proper denominator. And here this says, and that's why you have to write all this out at the beginning. A gets assigned to x plus 4. Our a value was negative 1/12. So it's negative 1/12 as the numerator to x plus 4. Next is b gets assigned to x minus 2. b was positive 1/12. So positive 1/12 over x minus 2. And then the third fraction on your decomposed side is c. c is equal to 1/2. And 1/2 gets assigned to x minus 2 with a power of 2 on it. And we're going to look for the answer that's like that for number 52. So let's see. A negative 1/12 with the x plus 4, a positive 1/12 with the x minus 2. The fractions don't have to be in this order, just as long as you have the correct numerator with the correct denominator. And then a 1/2 gets assigned to the x minus 2, and that would appear to be choice A, has everything properly situated. Okay, let me just check that answer on the answer key. So this is number 52. We said it was A, and that's correct. Okay, I'm going to end this video here, and I will pick up in the next video with problem 53. Okay, so we got up to 52, and in the next video we will continue with partial fraction decomposition.